Hey guys, for today we are doing some more systems of equations. We're setting them up and solving them from what's given, and that's going to be picture problems. So instead of an equation with numbers and variables and coefficients and all that given to us, it is images, and we create the mathematical equation and then we set them up and solve them. You'll have the option to solve these either with substitution or elimination. There's no graphs given for you to try and graph these unless you do that on your own separate sheet of paper, which I feel like might be more work. Tomorrow you will have a worksheet to work on where some of them are word problems, which you can use either elimination or substitution, and then some of them are graphs, which you can solve by graphing. So you'll have plenty of practice tomorrow to do all three, but today for these picture problems, I'd prefer you to choose either the elimination method or the substitution method to solve. So in your notebook, this is going to be page 66 and 67, and I've attached these to the Google Classroom for today. Cut them out, glue them in. Like I said, they will take up 2 pages, so we're going to go to those now. And out of the 4 problems, the first 2 I will do with you in this video here. The third one you'll set up by yourself, and the fourth one you get to actually create a situation in which you've got 2 items and you've got a total. And you'll create the images, you'll set up the equations, and then you'll solve it as well. So the fourth one you actually get to make all by yourself. So let's turn to that page now, and let's take a look at problem number 1. So the best thing to do is to think of 2 things that go together, and you'll see this as we go through these examples together. When you have to make your own equation for number 4, think of things that work together, like baseballs and baseball bats, burgers and a drink, cats and dogs, socks and shoes, apples and oranges, things like that. And you can just say, I have this many apples and this many oranges, and you make up a total. And then you'll do another scenario. This time I have this many apples and this many oranges with a different total. And you'll set those up and solve. And in that, you'll be able to figure out what each one should cost based on the way you set them up. So let's do number 1, and I'm going to do substitution to solve for this one. And number 2, I'll use elimination. So just to give you some more experience with both of those, and you can choose which one you prefer again. So like I said, they are pictures. They're not exactly numbers and variables and coefficients. So we're going to make one of the items an x and one of the items a y. So down here for variable number 1, which is x, I'm going to let that represent burgers, and I'm going to let y represent drinks, right? So if we don't know the cost of something, but we know how many we have, we just put a letter there. So I know I have 2x and 3y. I don't know how much they cost, but I know that I have 2 x's or 2 burgers and 3 drinks or 3 y's. So this is 2 x's and this is 3 y's. And then down here in this equation, I have 3 x's because x's represent burgers, and only 2 y's or only 2 drinks. So when I write these equations, I'm going to write them up over here. This would be 2x plus 3y equals my total of $10.25, right? And then this one right here, 3x plus 2y equals 11. These are my 2 equations from these images that we got. We have set them up. We've created the equations. Now, if I would need to solve these equations using each of them, like using them to help me figure this out, I have the elimination or substitution method. So we're going to use substitution. Since this one is a smaller equation, it has whole numbers and some of them are much smaller and easier to work with. I'm going to just move everything away from the y and get y equals everything else. So that way I can substitute all of that information in place of y right here. So whatever I get for y is going to go up here for y. So I'm going to move this over. And again, this is the substitution method. That's the same thing as negative 1.5. So if you prefer not using fractions, you can leave it as a fraction, but if you prefer looking at them as decimals instead of improper fractions, feel free to use your phone or a calculator to change that. It's not going to change the number or the answer. And then 11 over 2, well, 2 goes into 11 5 times, which makes 10, right? 2 times 5 is 10, and there's 1 left over. So that's the same thing as 5 1/2. So if you want to leave them as improper fractions, you can. If not, that's fine. So anyways, y equals this. So anywhere you see a y, you can plug all of that in place of y. So we're going to go up here. And in place of, that's a horrible arrow. In place of the y, I'm going to put what I just solved for and what I just found out. So in this equation, we have 2x plus 3. This is where this gets plugged in. Negative 1.5x plus 5.5 equals 1025. So my equation 2x plus 3y equals 1025, but instead of the y, I plugged in what I know y is. So this is the substitution method. And at this point, you will just distribute, simplify, and start moving everything away from your x value. So 3 times negative 1.5, let's plug that into our calculator, is negative 4.5. Keep the x with it. And then 3 times 5.5 is positive 16.5. And then we'll bring down the 1025 and bring down the 2x. I don't need to bring this down because this was distributed to this. So this times this gave me that. This times this gave me that. So don't bring this back down again when you've already used it. At this point, you're going to combine like terms. So I know a 2x and a negative 4.5x are like terms. They both have an x. So I'm using my phone right here. So if you're, if you use a phone as well, you can see how I do this. So negative 4.5 plus 2, I just use the numbers, and then I know that there's going to be an x attached to that. So you can't plug in the x in your phone. That's okay. You can look at your numbers and combine them. So that would be negative 2.5x, and then bring down the plus 16.5 and bring down the equals 10.25. And then again, I'm solving for x. So I'm going to move this over. Once you have all of your equations simplified and your terms combined, you start moving everything away from the letter that you're solving for. So that goes away. So 10.25 minus 16.5, again, 10.25 minus 16.5 is negative 6.25. Bring down the negative 2.5x. And the last thing you'd have to do is to get rid of that negative 2.5 by dividing it away. And your x will be divided by negative 2.5, $2.50. Now your phone isn't going to put that 0 at the end because it doesn't need it, but if we're talking in money, we do want to represent it that way. So we just figured out that our burgers cost $2.50. Now that we know this, we can plug this back in where x is down here and figure out what y is. So take this, plug it in right there, and solve for y. So at this point, you have, go back to my calculator, erase everything. I'm just going to type this whole thing in, negative 1.5 times what our x is. Sorry about the light. And we just solved that our x was $2.50. And then add 550. That means our drinks are $1.75. And so this is using substitution method. Take one of your equations, solve for the variable, get everything away from it, and use that and plug it in place of the variable in the other equation. And that way you're always solving for one variable at a time. Originally, you're solving for your y, getting everything away from y, and then when we plug that in, you'll see there are no y's. We're only solving for x's at this point, getting our x's together and solving for our x. Once you know your x, take it back to the other equation and plug it in, and that way you know what y is. So that is substitution. Again, it's a little bit longer, not my favorite, but it is a working method. Now let's look at number 2. Let's say 1, 2, 3, 4. Let's say our apples are x's and our bananas are y's. Okay, so I'm just counting how many of each that I have. So apples are going to be our x value. Bananas will be our y value. And then down here I have 3 apples and 1, 2, 3, 4, 5 bananas. So for this, I'm going to put it way up high up here. So we have 4x plus 3y equals $4.65. And then we have 3x and 5y equals $5.55. And looking at these two equations, again, I'm going to do elimination for this one to show you both ways. I've stacked these like terms on top of each other. Now, none of these like terms cancel each other out, so I'm going to have to multiply by something. So what I'm going to do is I'm going to actually get rid of these x values, which means I have to multiply both equations, because I can't just multiply one of them and get it up to equal the other. I have to multiply them both to get to a common factor. So I know that they can both get up to 12. 4 times 3 gets me to 12, and 3 times 4 gets me to 12. One of these has to be the opposite sign though, so I'm just going to make this one negative. So when I multiply 3 times 4x, I get 12x, and when I multiply negative 4 times 3x, I get negative 12x. So then I can have those cancel out. So I'm going to move down here where I have a little bit more room. 3 times 4x is now going to be 12x. 3 times 3 is 9y. And then 3 times 4.65 is 1395. Now let's do the bottom equation. Negative 4 times 3x is negative 12x. Negative 4 times 5y is negative 20y. And negative 4 times 555 is negative 2220. So now my new equations, this first equation is tripled. All of the values are 3 times bigger. And these, all of the values are 4 times bigger, but they're all the opposite signs that they were originally. Now I can eliminate my x's completely and just solve for y's. 9 minus 20, if that confuses you, do 20 minus 9. And it's 11. And then you keep the sign of the bigger number. Well, 20 is bigger than 9, and it's negative. So we're going to keep that. Bring down your y, and then do same thing here. Flip them, find the difference. 2220 minus 1395 is 825. And keep the sign of the bigger number. 2220 is bigger, and it's negative. So our answer is negative. At this point, we have one last thing to do to get y by itself, and we have to divide away that negative 11 that's stuck to it. And then plug this into your calculator. Negative 825 divided by negative 11 will give you 0.75, which is also in money terms, if we're talking about how much things cost and the price of them, that's less than a whole number. That's less than a whole dollar. So that would be 75 cents. So y, we just figured out, is 75 cents, right? And then we use that, plug that back into either one of these and figure out what the other letter is. So I'm going to plug this back into, we'll just go with the top one. So I'm just going to draw an arrow way up here and plug it in. So when I do that, we end up having 4x plus 3 times 0.75 equals 465. So we plug this value back in there. So I'm going to write it right here. 4x plus 3 times that 0.75 value equals 465. So we're plugging it back in. Well, 3 times 0.75 actually equals $2.25. Bring this down. and the 465 down. Move this to the other side. So if we take away $2.25 from 225, that goes away, leaving 4x to equal 465 minus 225, which is $2.40, and then divide away that 4 that's stuck to your x. I'm running off my paper here. And that equals 0.6 is what my phone says. So I'm going to add that 0 since we're talking about money. And that means that my apples are 60 cents. All right, so I took this y value and plugged it back into this original equation, and you can see the work right here for that to solve for the other letter. And if you want to double check your work, which is never, ever a bad idea, let's take a look. Let's plug these values into the equation and see if it works. 4 times x, which we found out was 60 cents, plus 3 times y, which we found out was 75 cents, equals 465, equals 465, which is correct. And remember, when you're plugging in 60 and 75 cents, that's 0.60 and 0.75, because a whole is 1.00, that's $1. So less than that is going to be a decimal number. And so you can always check your work and go back, because sometimes this looks right, but when you actually plug this back in, it doesn't work out to equal what it's supposed to equal. Now the next two you are going to do on your own. So this number 3, they give you the diagrams and the totals. You fill your information in here. Miss Carter went shopping at her favorite store, TJ Maxx. She bought 4, so it's talking about this one, 4 shirts and 2 pairs of leggings for $140. The next week, she went back to the store and bought 2 shirts and 3 pairs of leggings for $150. How much did she, Miss Carter, pay for one? And you can choose whichever one you want to figure out, a shirt or 1 pair of leggings. Let's say I said shirt. Well, down here you'd have to figure out, well, does shirt equal your X's or does shirt equal your Y's? And I would make shirts my X's, leggings my Y's, set up my equations, and you can either use elimination or substitution to solve for your X's. Once you know what your X value is, and you plug it all back in, you can figure out how much 1 shirt costs and how much 1 pair of leggings cost, because that's exactly what we did in the previous problems. We figured out how much exactly 1 burger and 1 drink cost, and exactly how much 1 apple and 1 banana cost, using whichever method you prefer. And then for the last one here, you get to create your own story, draw 2 diagram equations with objects, and then write the story that represents your diagrams. You're not going to be able to trade papers and set up the equations because you guys are at home, but all I want you to do for this one is to just set it up. You don't have to solve it, because obviously you're going to know what the answer is because you're making it up. But you can draw, like I said, 2 buckets and 3 mops to equal something, and 4 buckets and 1 mop to equal a different answer, and then write it algebraically, what those 2 equations would be. So you're going to do these on your own, and if you have questions, as always, feel free to let me know. But this goes into your notebook, page 66 and page 67.